Hello students, today I am going to start our second unit and that is about the differential equation. Now let us see what is differential equation. An equation containing dependent variables, independent variables and the differential coefficient of dependent variables with respect to independent variables is called differential equation. That means any equation which contains the differential coefficient or derivative of dependent variable with respect to one or more independent variable is called differential equation. For example, this is a differential equation because it involves this derivative of y with respect to x. It is d2y dx square minus 3 dy dx plus 2y equal to 0. There are many more examples. So if differential equation actually are of two types, one is ordinary differential equation and the second is partial differential equation. A differential equation which involves ordinary derivative is called ordinary differential equation. On the other hand, if it consists of partial derivatives, then it is called partial differential equation. So this is the example of ordinary differential equation because it involves only ordinary derivative. And this is del 2u by del x square plus del 2u by del y square equal to 0. This is an example of partial derivative. Now, what is the order and degree of a differential equation? Actually, the order of the differential equation is the highest order derivative present in the differential equation. That is, whatever in the equation, whatever the order of the differential equation will determined by the highest order derivative present in that equation. And what is the degree? The power of the highest order derivative in the differential equation is called the degree of the differential equation. That means we have to check only the power of the highest order derivative occurring in the differential equation, provided the differential equation is expressed as the polynomial in derivatives. For example, suppose this is a differential equation, it is a polynomial of derivatives. Now this equation, we have to find the degree and order of this differential equation. You can see that this is the d3y dx cube plus 2 d2y dx square the whole square minus dy dx plus y equal to 0. Here the highest order derivative involved in this equation is 3 d3y dx cube. This is the highest order derivative. So the order of the differential equation will be 3, the highest order derivative presenting in this equation. To check the degree, we have to check only the power of this highest order derivative. No need to check the highest power of d2y dx square because this is not the highest order derivative present in this equation. In this equation, the highest order derivative is d3y dx cube. So check the power of d3y dx cube. The power of d3y dx cube is 1. So the degree of this differential equation is 1. Now, in the second example, dy dx whole square plus dy dx minus sine square y equal to 0. Now find the order and degree of this differential equation. This differential equation, the highest order derivative is first order derivative, that is dy dx. This is the highest order derivative present in this equation. So the order of this differential equation is 1. But what is the degree? But the degree of this differential equation is not defined because this differential equation is not a polynomial in dy by dx. The differential equation, to check the degree, the differential equation must be of polynomial in y or polynomial in dy by dx. But since this is not a polynomial in derivative, so we cannot define the degree of this differential equation. Now there are some questions given in your first exercise. These are the differential equation. You have to find the order and degree of the following differential equation. The first is d2y dx square plus a square x equal to 0. Now you can observe that in this equation the highest order derivative is 2 because d2y dx square. So the order of the differential equation is 2. And what will be the degree? You have to check the power of this highest order derivative. Is power is 1, so degree is 1. The second question, it is given 1 plus dy dx whole square whole to the power 1 by 2 is equal to d2y dx square. Now you have to check the order. The highest order derivative is 2 d2y dx square, so order is 2. To check the degree, first you have to express this equation in polynomial of dy by dx. That means we have to make it radical free. Radical means since this root, square root, cube root, these are the radicals. To find the degree of any differential equation, first you express the equation, you make the equation radical free. To make it radical free, or you can say you can express this as polynomial in its derivative dy by dx. So to express this in polynomial, first square both sides. After squaring both sides, we get 1 plus dy dx equal to d2y dx square का whole square. It will be square d2y dx square का whole square. यहाँ पे square होगा. Okay. Now check the degree. That means you have to check the power of the highest order derivative involved in this equation. The power of highest order derivative is 2. So the degree is 2. Is it clear? Now, in the next question, x square d2y dx square whole cube plus y dy dx whole to the power 4 plus y to the power 4 is equal to 0. Now its order is 2 because the highest order derivative is d2y dx square involved in this equation. And what is the degree? Degree, you have to check the power of highest order derivative of this equation. Its power is 3, so the degree will be 3. No need to check the power of dy by dx because this is not the highest order derivative involved in this equation. The highest order derivative is 2. So check the power of this highest order derivative. Since it is 3, so the degree of this differential equation will be 3, so order will be 2. Likewise, you can solve, you can determine all the order and degree of the remaining questions. Now this is a very small note that the degree of the differential equation which is not a polynomial in derivatives is said to be not defined. That means what I told in the last example, that if here, if it is not a differential equation, it, it is a if it is not a polynomial in derivatives, then we cannot determine the degree of these differential equations. Okay, to find the degree, the differential equation should be a polynomial in dy by dx. And next come to the solution of differential equation. What is called the solution of differential equation? Actually, a function y equal to fx involving a number of arbitrary constants is called the solution of differential equation if it satisfies the differential equation. That means any function which involves arbitrary constant is called the solution of differential equation if it satisfies the given differential equation. Okay. Now for example, suppose y equal to mx is the solution of the differential equation x dy by dx minus y equal to 0. That means this is a function of x containing arbitrary constant m is the solution of this differential equation x dy dx minus y equal to 0. Now let us check whether this is the solution or not. If it is a solution of this differential equation, that means this differential equation must be satisfied with this function y equal to mx. Now to check, first differentiate the solution of differential equation containing the arbitrary constant. So y equal to mx was the solution. First differentiate it with respect to x, it will be dy by dx equal to m. Now just substitute the value of dy by dx in the left hand side of the given differential equation. Then it will be x dy dx minus y, that is x into, in place of dy by dx we will write m. So mx minus, place of y you can write mx, this is the solution. So minus mx, so mx minus mx is 0. That means y equal to mx satisfies this relation x dy dx minus y equal to 0. That it implies that y equal to mx is the solution of the differential equation 1. Clear? Now on the other hand, we can say the number of arbitrary constants in the solution of a differential equation is equal to the order of the differential equation. That means the number of arbitrary constants present in the solution, that will determine the order of the differential equation. That means the number of arbitrary constants present in the differential equation, that many times we have to differentiate the solution of the differential equation, and it will determine the order of the differential equation. Next, the formation of differential equation, that means solution of differential equation, that means a function which satisfies the given differential equation is called the solution of differential equation, which contains the arbitrary constant, and the number of arbitrary constant present in the solution determines the order of the differential equation. That means we have to differentiate it that many times, the order of the arbitrary constant present in that equation. If there is only one arbitrary constant, that means we have to differentiate it only once. That means it will be a first order differential equation. If there are two different arbitrary constant present in the solution, then we will differentiate it twice, and then we will get a second order differential equation. Now how we can form a differential equation? That means if the solution is given, then find the differential equation. So differential equation can be formed from the solution by simply differentiating it and then eliminating the arbitrary constant. That means formation of differential equation involves two steps. In the first step, you have to differentiate the solution, and in the second step you have to eliminate the arbitrary constant present in that equation. It means, for example, if y equal to a cos x plus b sin x is the solution of differential equation. This is the solution of any differential equation where a and b are arbitrary constant. Now the question is, you have to find the differential equation whose solution is this, y equal to a cos x plus b sin x. Okay, we are going to form the differential equation. So this is the formation of differential equation. So take the solution y equal to a cos x plus b sin x, where a and b are arbitrary constant. So to form, in the process of formation of differential equation, it involves two steps. But I told you the first step is differentiate the solution or the given solution. That means you have to differentiate y equal to a cos x plus b sin x with respect to x. So it will be dy by dx equal to minus of a sin x plus b cos x. Since there are two arbitrary constants present in this equation, these are a and b, so you have to differentiate it again. The number of arbitrary constant present in the equation determines the order of the differential equation. That means there are two arbitrary constant present in this equation. That means we have to differentiate it twice. So again we will differentiate this dy by dx. We will get d2y dx square equal to minus of a cos x minus of b sin x. If we take negative sign outside, it will be a cos x plus b sin x, and its value is nothing but equal to y. So we can write d2y by dx square is equal to minus of y. That means d2y dx square plus y is equal to 0. That means a cos x plus b sin x is the solution of this differential equation d2y dx square plus y equal to 0. Okay, now come to our exercise in page number 325. And the first, in the question number 3, it has been asked that find the differential equation of a system of circles touching the y-axis at the origin, whose equation is given by x square plus y square plus 2gx is equal to 0. So this is the solution. You have to find the differential equation of the system of circles which touches the y-axis at origin, and whose equation means the equation of the circle is given by x square plus y square plus 2gx equal to 0. So this is the solution. Now you have to form the differential equation of this equation x square plus y square plus 2gx equal to 0. First you check how many arbitrary constant is present in the solution. There are only one arbitrary constant, and that is g. So you have to differentiate it once. First differentiate it with respect to x. We will get 2x plus 2y plus 2g is equal to 0. So g will be minus of x minus of y divided by dx. Now substitute this value of g in equation 1. It will be the value of g. Just make it correct. It will not be y. We are finding the value of g because in the second step we have to eliminate the arbitrary constant now. So in place of g we can write minus of x minus of y divided by dx in the given solution, that is x square plus y square plus 2gx. So 2g, this is the value of g and x, and multiply this with 2x, we'll get x square plus y square minus 2x square minus 2xy divided dx equal to 0. That means 2xy divided dx plus x square minus y square is equal to 0. So this is the differential equation whose solution is given by x square plus y square plus 2gx is equal to 0. Okay, so in the first step we differentiate it with respect to x, and in the second step we substitute, we eliminate actually the arbitrary constant. That means we are substituting the value of g in equation 1, and then we'll get the required differential equation. And the next question, find the differential equation of all parabolas with lattice rectum 4a and whose axes are parallel to x-axis, whose equation is given by y minus k whole square is equal to 4ax minus h. Since it is given that the differential, we have to find the differential equation. That means it is the case of formation of differential equation of all parabolas with lattice rectum 4a and whose axes are parallel to x-axis. And that equation of parabola is also given, y minus k whole square equal to 4x minus h. Since it is already mentioned that lattice rectum is of length 4a, so we will not consider this 4a as arbitrary constant. This is a absolute constant. Okay, so only the arbitrary constant present in this equation is h and k. Since there are two arbitrary constants, so we will have to differentiate it twice. First, differentiate this given equation of parabola with respect to x. We'll get 2y minus k divided dx equal to 4a. That means y minus k divided dx is equal to 2a. Since there are two arbitrary constants, so we have to differentiate it again with respect to x. We'll get y minus k by product rule d2y dx square plus dy by dx whole square is equal to 0. That means y minus k d2y dx square is equal to minus of dy dx whole square. Now we divide 1 by 2 and we'll get this equation, and after the simplification we'll get 2a d2y dx square plus dy dx whole cube is equal to 0. So this is the solution of the given differential. This is the differential equation of the parabola, given parabola y minus k whole square equal to 4x minus h. And the next question number 5, you see, find the differential equation which has y equal to a cos mx plus b. You have to find the differential equation which has y equal to a cos mx plus b for its complete integral a and b being arbitrary constants. So this is the solution, and you have to find the differential equation whose solution is this. How many arbitrary constants are present here? There are two arbitrary constants a and b. It is mentioned that there are two arbitrary constants a and b. That means we have to differentiate it twice. So first, differentiate it with respect to x. We'll get dy dx is equal to minus of am sine of mx plus b. Here m is not an arbitrary constant, it is treated as absolute constant. Again, you have to differentiate dy dx with respect to x. You will get d2y dx square is equal to negative of am square cos mx plus b. Now equation 1 and 2 is there. From equation 1 and 2 we get d2y dx square minus of m square y. That means if we take it in the left hand side, we'll get d2y dx square plus m square y is equal to 0. So this is the differential equation. Okay, there is no arbitrary constant a and b present in this equation. So this is the answer. In question number 6, question number 6 is very important. We have to form a differential equation of which y equal to e to the power x, a cos 2x plus b sin 2x is the solution. And it is also mentioned that a and b are arbitrary constants. And this 2 is absolute constant. Only a and b are arbitrary constant. So there are two arbitrary constants. So we have to differentiate the given equation twice, and then we have to eliminate this arbitrary constant also. So first you differentiate with respect to x by product formula. We'll get dy by dx is equal to e to the power x minus 2a sin 2x plus 2b cos 2x plus e to the power x a cos 2x plus b sin 2x. Now this equation can be written in this form. If we take 2 outside, so it will be 2 e to the power x is equal to minus a sin 2x plus b cos 2x plus this whole term is equal to y. So instead of this, write y. Now again differentiate this with respect to x because there are two arbitrary constants. So again we have to differentiate dy by dx. It will be d2y dx square is equal to 2 was already there. Now use the product formula e to the power x. Now differentiate this. We will get minus of 2a cos 2x minus of 2b sin 2x plus, now this whole term will remain same. Product of first function derivative of second, now second function derivative of first. Derivative of first is e to the power x itself, so it will be this term only. But this whole term can be written in the form of dy by dx minus of y. If we take this y, the left hand side, we will get the value of 2 e to the power x minus a sin 2x plus b cos 2x, and that is nothing but the differential. uh, uh, in place of this we can write dy by dx. So if we differentiate y, we'll get dy by dx, but in place of this we will write in place of this we can write dy by dx minus y. Okay, you can see this, that in place of 2 e to the power x minus a sin 2x plus b cos 2x, this term can be written as dy by dx negative of y. So substitute here dy by dx negative of y, and we will get the following differential equation. After simplifying this, we'll get d2y dx square minus of 2 dy dx plus of 5y is equal to 0. So this is all about the formation of differential equation and the solution of differential equation we will study in the next lecture. Okay, thank you for watching the video. We'll see you in the next video. Bye bye.